Hello. This is a great lesson today, the Pythagorean theorem. The Pythagorean theorem goes back a very long time. The EQ today is about Pythagoras. If you do not know the answer, you may have to Google it or look in your textbook. All right, so let's review and talk about a right triangle. We need to make sure we know the parts of it. So you have a right angle, and the two sides that make up that right angle are called legs. The hypotenuse is always the longest side and is always opposite across from the right angle. The other two sides, the other two angles are acute and complementary. That means they have to add up to 90. So looking at a triangle, you really have to look at how it's sitting. And we always have to make sure where the hypotenuse is. So look at these two right triangles. Where's the hypotenuse? Right, so for this one, it is D. It's opposite the right angle. And for here, it's sitting on its hypotenuse, but still opposite the right angle. So the Pythagorean theorem, people often just think it's a squared plus b squared equals c squared, but that's only part of it. It's usually stated in this way in words, in a right triangle. And that's the most important part people forget. In a right triangle. This doesn't work for obtuse triangles. It doesn't work for acute triangles. Has to be a right triangle. And if it's a right triangle, then the other part is true, which is the length, the square of the length of the hypotenuse. Okay, that's here. Square of the length of the hypotenuse is equal to the sum of the squares of the length of the sides. Length of the legs, which here are A and B. So those are the letters that are used often for the Pythagorean theorem, A, B, and C, but it could be X, Y, and Z. It could be J, K, L. It could be happy face, sad face, teddy bear. You just have to define your variables. So here I've defined it in the diagram in the picture. A and B are the legs, and C is the hypotenuse. Now this is generally what people think of. If a triangle is a right triangle, then a squared plus b squared equals c squared. Again, you have to make sure that c is the hypotenuse and a and b are the legs. So remember in the Pythagorean theorem, c squared is always the hypotenuse, the longest side. No matter how it's sitting, we always have to remember c represents the hypotenuse. All right, so let's practice this. All right, so you can see that the directions ask us to keep our answer in simplest radical form. So we're not going to use a decimal. All right, so I'm looking at my picture. So first of all, what do we know? What do we see? I see it's a right triangle, okay? And I'm given two sides. And what are those two sides? They're both legs. So this is going to be our hypotenuse, or C. So using this equation, and it doesn't matter which one's A and B. This could be A or B. This could be A or B. They're just the legs. So I'm going to do this. Okay. Now once we get here, we're going to take the square root, right? That will undo the square, and the square root are inverses of each other. Now when we're going to simplify 45, remember we're looking for perfect squares, so it's 9 times 5. The square root of 9 is 3, and then it's root of 5. Double check, no units, so this is my final answer. All right, here's two more problems. You may want to try them on your own. Pause and then unpause when you're done. So again, let's look and see what we have. Is it a right triangle? Yes. Am I given two sides? Which is a hypotenuse. This is going to be my hypotenuse. Right, so I'm going to have x squared 5 squared equals 13 squared. So remember, just because it's a variable, that doesn't mean it's over here. Again, it's always the longest side. Okay, gonna subtract. All right, and we're gonna take the square root. Now when you take the square root, it is plus or minus 12. However, because we're talking about a length of a side of a triangle, that can't be negative. So we only take the positive. The answer is 12. All right, so this one, okay, next one, which is a hypotenuse. Hypotenuse, let's see, 4 squared plus x squared equals 8 squared. Okay, so let's look at this. Okay, it could be 4. That's probably what most students think of when you're looking at that. So you're probably thinking 4 times 12. Okay. So 4 is the square root of 4 is 2. But the 12, I can still simplify that. That's 4 times 3, which 4 is 2, but I already have the 2 out there. So it would look like this. Okay. So 2 times 2 is 4. Now another way, if you saw immediately that 48 was 16 times 3, then you could say the square root of 16 is 4, and then you have the root 3. All right, let's see, more problem. All right, so over here, number 4, which we have, it looks like a square, and wants to know the length of the diagonal. So this is also, so you can see there's a nice right triangle. So now we're going to do squared. Be careful when you square this. So when you do it, please remember it's actually this. So you're saying 6 times 6 is 36, and root 2 times root 2 is 2. Because root 2 times root 2 is root 4. And the square root of 4 equals 2. Plus, so that's going to be the same thing. So it's going to be 72 plus 72, which equals 144. So the square root of 144 is 12. And this one has units, so we're going to do inches. Okay, let's try this one. All right, well, this one's similar. We have 2 sides that are equal, but this is n. So this is n, this is also n. All right, so you can still use the Pythagorean theorem. This is going to be our hypotenuse c. So n squared plus n squared equals 8 squared. So 1 n squared plus another n squared is 2n squared equals 64. So you're going to take the square, divide by 2. So n squared equals 32. We're going to take the square root of that. Now 32 is 16 times 2, and the square root of 16 is 4 root 2, and we're in feet. So that was the Pythagorean theorem. Now there's also the converse of the Pythagorean theorem, which is equally as important, but just used very differently. This is important because it proves something is a right triangle. So it says this: if the square of the length of the longest side of a triangle, if we don't know if it's a hypotenuse, it's just the longest side, is equal to the sum of the squares of the length of the other 2 sides, then the triangle is right. So if we're saying, hey, this longest side, I think this is, because if it's going to be the hypotenuse, it would have to be the longest side. So if it's the longest side squared equals the other 2 sides, the sum of the other 2 sides squared, then it has to be a right triangle, which is a very interesting concept. It forces this to be a right angle. And they use this method in construction. And even to this day, they still use this method of using lengths to make sure that the angle is right, or what we call square. Right, so we're taking this and we're going to see, all right, if this equals, then it's a right triangle. So now in the textbook, it doesn't have these two other conjectures, but it also proves, so you can, using Pythagorean theorem, you determine if it's right or not right. So if it's not right, well, you have two more possibilities, acute or obtuse. And these two ideas explain which one's which. So now you can determine if it's not a right triangle, what is it? So here, if c squared is less than the other two sides squared, then it's an acute triangle. Because these two are bigger than this one, so it'll make this c smaller, right? But if the c squared is larger than both of them, right? So you can see it's going to be longer, which pushes the other two sides away, which makes this angle bigger. Then it's obtuse. So if it's equal, right triangle. If c squared is less than a squared plus b squared, acute. If c squared is bigger, obtuse. All right, so let's look at this and determine if it's right, acute, or obtuse. So this is how I write it. So this is my longest side, right? So I'm going to say 97 squared something. Does it equal or not? I don't know. Is it equal, less than, greater than? I don't know. So this is what I have to figure out. Okay, so don't put an equal there because we don't know. So I put my question mark. It might be less than for all we know. So using my calculator, I know this. I'm still showing my work. I don't know about that. Okay, are they equal? So this is that. If I add them together, I get this. So yes, they are equal. So what can I conclude? Well, they're equal, then it's a right triangle. So for the next one, all right, what is the longest side? Well, the longest side looks like this one, right? And you're going to say, but it's 3 root 5. Well, if you use your calculator, root 5 is approximately 2.236, and you times it by 3, and that's 6.7. So that is longer than 6. So same thing, this is going to be my longest side. So I'm going to say, all right, I'm not sure what that is. I don't know if it's equal, less than, or greater than. It's something to these two. Let's see and figure that out. So remember, this is going to be 9. Right, 3 times 3 is 9. Sorry, 3 squared is 9. Square root of 5 squared is 5. This is going to be 4 plus 36. So this is 45, and this is 40. All right, so 45 is bigger than 40. So if the one side is bigger than the sum of the other two, this is obtuse. I always think it's like 1 beats 2 of them. 2 of them together still is not bigger than that. So it must be obtuse. Oh, obtuse triangle. All right. All right. Don't forget to answer the EQ. Thanks for watching. Have a good day.